Okay, so now that we've covered the way in which we can use Java 8 streams in order to search for the items and print the items and so on, let's talk a little bit about how a spliterator is used internally in order to search for the phrases, in order to be able to take each phrase we're looking for and turn it into a search results object. And this is kind of what it's going to do. So we're going to take a look at this code in a second. And then if we have time, we may not get to this till next time. We'll talk about the pros and cons of this approach. All right, so if you recall, a spliterator is used for two things. It's used for returning each element to traverse a collection, to traverse a stream. That's one of the things it's done, and that's for sequential streams. And it's also used to break things up into chunks by splitting them, and that's what's used for parallel streams. And there's a classic Saturday Night Live skit about the shimmer non-dairy floor wax, and they always said, it's a dessert topping, it's a floor wax, right? It's good for two things. So that's what this is. This is good for multiple things. We're going to talk about the sequential stuff right now. We'll come back and talk about the parallel stuff next week. Here's where this gets used. There's a method called search for phrase. That's the guy that actually does the searching, takes the phrase, the input string, the title, and a flag that indicates how we want to do the search. And under the hood, it uses a stream support.stream factory method, which I mentioned to you briefly before when I talked about what stream does on Java collection. And what this does is it takes an instance of our spliterator that I'm about to show you, and it is going to go ahead and turn that into a stream by using the spliterator to split the stream into phrases that matching phrases. And it passes in a flag that says, is it parallel or not? Right now, the answer is false. It is not parallel. Later, the answer will be true, but all that will change is the Boolean will be true instead of false. So that's pretty cool. Here's how this is used in the overall scheme of things. We're going to have the map method called search for phrase. That's where this processing is about to take place. So it's where we go from a stream of strings to a stream of search results. Here's an example. We're looking for the phrase brevity is the soul of wit, and we want to basically get back a search result that indicates what index this occurred in the input. Here's what the code looks like. It implements something called a spliterator. We talked briefly about that before. That's an interface that defines a number of methods. The two most relevant ones for our discussion are try_advance and try_split. There's a whole pile of fields here that we'll talk about shortly. This is the string we're searching. This is the phrase we're looking for. This is the regular expression pattern matcher that we use in order to search for the phrase, which could split across lines. We keep track of the min split size. We won't talk about that right now. And something called moffset. We won't talk about that right now either. Some of these fields are updated in the try_split method, which we'll talk about later. So that's why they're not final. Does anybody remember what a final qualifier does? What does final mean in Java? Close. For a method, it would. So the answer was the potential response was it prevents it from being overridden. That's true for methods. So methods, if a final method cannot be overridden, that's correct. But for fields, it means something slightly different, although not too much different. Yeah. Once its value is set, either in the initializer section or in the constructor, it can't be changed. Exactly. As a general rule of thumb, it's good to use final fields as much as possible because it makes your objects so-called immutable, which are good for various things. Here's what the regular expression processing looks like in the constructor. We're going to go ahead and make ourselves a regular expression phrase, which is some really wacky, crazy regular expression stuff where we get rid of the leading spaces, make the phrase be a word, and then we go ahead and we go through the entire phrase and we replace everything to make each individual word be a separate word so it only matches words, not substrings. It's a crazy regular expression. We then compile this regular expression into a pattern matcher in a case-insensitive way that will span lines. Then we call the matcher method. That goes ahead and makes a matcher on the input. You'll see how that's used in a second. So a matcher is what's used when the program actually does the try_advance call to try to find the next element in the input string that matches the phrase. And then we do a little bit of stuff related to the split size, which I also want to talk about right now because the sequential version doesn't split. Here's the try advanced method. As you can see, it plays the role of has next and next in Java's iterator interface, but it's a little bit more concise and easier to work with. The find method on the matcher will go try to find the next occurrence of the phrase in the input string. We had a question the other day about, doesn't it start over again from the beginning? Each time it's called, no, it remembers where it left off. So every time it's called, it starts right past where it found the last item, if it found it. If there are no more matches, we're done. Otherwise, if there is a match, we figure out where the match occurred, and we make ourselves a new result object, and we then make that be the value. The new result with the start is the thing we accept into the consumer action. So this is basically an out parameter that we're passing back to the caller. And then we return true in that case because we need to keep searching. Trisplit is something that we'll talk about later. Okay, any questions about that? So we can cover the pros and cons really fast. So there are a number of benefits with using streams versus writing this without streams, which is painful, having done it. It uses something called internal iterators versus external iterators. I'll cover that in more detail. The main point of internal versus external is you don't see the iteration directly. It's done implicitly by the streams framework. And that shields the programs from implementation details of how it all works under the hood. It's also a nice declarative pipeline since we're transforming things through these aggregate operations. And that allows us to focus on the what, not the how. The framework does the how, we just do the what. So that's a reduction in complexity. The lambda expressions, the lambda functions we're using here don't have any side effects. The behaviors we're passing in, so they're all self-contained. And that means that we don't have to worry about runtime race conditions. It's easier to think about what our program does because we just have to look at the method implementation, the implementation of the lambda, and we kind of know what it's doing. We don't have to go look at side effects and examine global variables or other things like that. However, there are some downsides, and the biggest downside is it's a sequential implementation. So it can't take advantage of multi-core processors. So there's just one thread of control. And if you look at the performance on my monster laptop here, my Lenovo laptop has 32 gigs of RAM, super quad-core, hyper-threaded. It's awesome beast of a machine with solid state drive and so on. And it's pretty darn fast, but look at how much slower it is than the fastest version, which is more than 4 times faster. So it's better. It's not too bad. In fact, you can see that the version that doesn't use streams is only a few milliseconds faster, but that's in the order of noise compared to the speed up we get from parallelism. We also only use a handful of aggregate operations. There's dozens of them. And the good news is these are also useful for parallel streams. There's lots and lots and lots more stuff. We will cover some of that in later examples in the course, and you'll get to play with some more of the examples as well. Okay, so that is the end.